Every dot on this map represents one or more AI companies. The color tells you the region. Blue is North America, green is Europe, red is Asia and the Middle East, and gray is other. The number on a dot tells you how many companies it represents. I'll click on the green dot in Europe. And the dot in France. The size of the dot tells you roughly how many people work at that company. Let's click on a particular dot. You can see information about this company, including links to its company site and its Wikipedia page. To make this map, I used Python to scrape a list of AI companies from Wikipedia, extracted structured data from individual company articles on Wikipedia, converted their addresses to coordinates, and dropped all that information onto an interactive map. I used 3 Python libraries and no JavaScript. Let's walk through how it works. A couple of things before we start. First, this is a teaching project, not a production application. I've kept the code clean and readable rather than defensive. In a real pipeline, you'd add retry logic and more robust error handling. Here, the goal is clarity. Hopefully, you can read this code and understand exactly what it does. The code is on my GitHub. The link is in the description. Feel free to fork it, play with it, and improve it. Leave a comment of what you've done with it. The pipeline has 3 stages, each of which uses a different library. Stage 1 is input. We read data from Wikipedia. The raw data is HTML. BeautifulSoup lets us navigate that tree like a Python object and pull out exactly what we want. Stage 2 is processing. We have company names and headquarters as plain text strings. The map needs latitude and longitude. We geocode, which converts place names to coordinates using Nominatim, OpenStreetMap's free geocoding service. Stage 3 is output. We take the geocoded coordinates and build an interactive map using Folium, a Python wrapper around Leaflet.js. From your Python code, Folium generates HTML and JavaScript. You don't need to know or use any JavaScript for this project. Folium does it for you. Now, let's look at the code. Let's look at the main function. So the main function orchestrates the rest of the code to step through the 3 steps that we just saw. And to create this map, it reads in the data, then it geocodes, then it makes the map. So first we create an output directory. We set up a parser. So this code will allow you to skip the scrape if you have already done a skip scrape and it has created the CSV file. Then there's no reason to do it again as long as the Wikipedia page has not changed. And then you can just load it from cache and save that step. Similarly with the geocode, if you've already created the scrape and the geocode and you just want to remake the map, then you can skip the geocode as well. Then we go through the scraping step. Yeah, if you've said to skip the scrape, then it just loads it from the cache file, validates that the data frame actually does exist and has the right columns. Otherwise, it will scrape the companies and save those to that cache file for later. Then we geocode the headquarters. Again, if you skip it, it reads it from the cache file. Otherwise, it creates that by calling this geocode company headquarters function, which we'll go through later. And then the third step, it generates the map. So it calls make map of of these companies and companies df, and then we're done. So let's see what this looks like. So I'll open up a terminal here. I created this project using UV. So let's use UV run main.py. I am not feeding it any of the arguments to skip the scrape or to skip the geocode. So I'll go through the whole shebang here and create an out directory that has those files and also the map. So here it scrapes the companies. It found 80 of them, and now it's cranking through all 80 of these. Okay, so the last few here, there's 80. Now it geocodes to headquarters. This takes a minute. And then it makes the interactive HTML map. It plotted 69 companies out of the 80. So presumably it found Latin long for those 69 companies, and it saved the map, and the program is complete. So what did that do? It created this out directory. Inside of that, we see the AI companies, which is a CSV file. So what did it do? So we see a company name, it's the URL for its Wikipedia page, its address, we'll geocode that later to find Latin long for it, the founding year, its company website, and the number of employees. The geocache, then it replaces the address with the latitude and longitude. And then finally, it has created this HTML map, which is what we saw at the beginning of the video. Each of the main files of the project handles a specific job. Config.py contains constants for URLs, paths, and headers. Utils.py contains shared helpers so as to not muddy up the code. Scrape.py uses the Python library BeautifulSoup to scrape data from a Wikipedia page. Geocode.py uses geopy and Nominatim to geocode the addresses to Latin long. Mapping.py uses Folium to create the map. And main.py orchestrates the stages of the program. Let's walk through each of these files in pipeline order. Everything that might change, URLs, file paths, or HTTP headers, lives in one place. If Wikipedia changes its URL structure, we can make changes here and let them trickle through the code without having to chase down all the places in the code that are affected. Notice the user agent. Wikipedia serves a strip page to unrecognized bots. By impersonating a real browser, we get the full page. No company data is used to represent empty data for a company. Let's look at the function fetch_soup. Every HTTP request in this project goes through this one function. It sets the headers, raises an exception on error, so if 404 doesn't silently return empty data, and hands back a parsed BeautifulSoup object. By centralizing this function, if something goes wrong with our requests, there's exactly one place to look. Now let's look at the validate functions. These are defensive checks. A data pipeline that fails silently is worse than one that fails loudly. If a stage receives a data frame without the columns it expects, we want to know immediately, not an hour later when the map renders blank. Now consider functions to clean up info box text. Wikipedia info boxes give us messy strings. A headquarters entry might read San Francisco, California, United States, bracket 1, with a footnote reference baked in. These three functions strip the noise, simplify to the last two or three address components, and normalize the result. Cleaning inputs now means better geocoding results downstream. This is the Wikipedia page, list of artificial intelligence companies. When your browser loads this Wikipedia page, it receives HTML. Let's look at what that looks like. So you right click somewhere on the page, doesn't really matter where. Choose inspect. And we see the HTML for this page in the DevTools window. I'm going to click somewhere inside of the DevTools window to select it. Control F to search. Let's look for Anthropic. Could have picked any of them. And we see in the HTML, Anthropic appears as a list item inside of an unordered list inside of this div that has class div column and has a style. So every company name is an anchor tag inside of a list item. So that's what we're targeting. BeautifulSoup lets us query that structure using CSS selectors the same way a browser would. Let's look at the function getCompanyLinks inside of scrape.py. So first we get the HTML code from the article with the fetchSoup function that we looked at before. And then from that HTML code, we select the links that start with wiki. So that's this line. Let's translate that into English. So it says, find every anchor tag inside of a list item, inside of an unordered list, inside of this kind of div that starts, whose href starts with wiki. So that's what that means. And then we loop through them. We pull out the legitimate hrefs from wiki links. So we've probably caught some stuff that is not actually a company. So let's look through the ones that we want to keep. Those we will keep in company links. Seen hrefs will keep track of companies we've already seen so that we don't add them twice. So for instance, Hugging Face appears twice in this article. You could pick the first one, you could pick the second one, you could do them both, you can handle it however you want. For the purposes of this tutorial, I've decided to just keep the first one. Then we step through this. If it's legitimate and not already in the list, add the link to the company links list. So let's see, if it's in seen hrefs, we continue. If it's a meta tag, the colon would be things like Wikipedia colon protection policy, some sort of meta page, which we are not interested in. If it's in the nav box, not interested in that either. If it's a list of something that's not a company name, lists, plural of, that would not be a company name either. So if any of those conditions happen, we boot out of this iteration of the loop. Otherwise, we add it to scene hrefs so that we don't add it a second time later, and add it to the company links. Here we're back at the Wikipedia page for list of artificial intelligence companies. Let's pick one. Let's pick Anthropic again and follow that. That takes me to the page for Anthropic. We see that there is an info box here on the right hand side that has Anthropic, its company type, industry, founders, etc. So we want to scrape information from this box. So let's take a look at what it looks like. So again, I right click, go to inspect, and I can see, there we go, I can see that this info box is inside of a table with class info box. So that should be enough to allow us to find information out of this info box. Let's look at the function parse company info box. So first we find the info box by parsing the soup object, and we see the object with table and class info box, which is what we just saw, that's what we're looking for. If there is no info box, return an empty one. Otherwise, we parse it. So we iterate through the rows, pull out the label and the data. If headquarters is in the label, then we look at the headquarters. We clean that text with a utility function. If founded is in the label, then we set the year founded, use some regex to get digits only. If website is in the label, a little bit of manipulation here to make sure it starts with HTTPS. If employee is there, then we grab the number of employees. And then we return the headquarters founded, the website, and the number of employees. This is the function scrape companies. So we get the company links. That's all that function. Print it out, loop through it to get company info. From that, we get the company info. We looked at that. Append it to this record. Sleep for half a second so that we don't hammer Wikipedia. Create a data frame. Validate that data frame. Make sure it's not empty and that it has the columns that we want, and return it. We have headquarters as text strings. So for instance, we might have as a string San Francisco, California, United States. The map doesn't understand that. It needs coordinates in latitude and longitude. So the conversion from place name to latitude and longitude is called geocoding. So we have a function here to do this for us. So at this point we have scraped the web page, and we have a company's data frame, company's DF. So we pass that into this function. It validates that it's not empty and that it has the correct columns. Then it calls Nominatim, the library that does the geocoding for us. Steps through the entries of the series, the company's data frame, and then the headquarters column. So that gets pulled out as a series. It iterates through that. Calls geocode address for each one of those headquarters and appends it to the company and returns that data frame, which now has latitude and longitude. This geocode address, that is a wrapper for the geolocator geocode function from Nominatim. And that's really all there is to it for the geocoding, really just wrappers to external libraries. Folium is a Python wrapper around Leaflet.js, which is the JavaScript library behind most interactive web maps. You write Python, Folium generates the HTML, no JavaScript required. The main block of code is this one we call a Folium map. We give it a location to start on, how far zoomed out it should be, what the tiles should be. There are different selections you can choose from. The minimum zoom. The world copy jump keeps there from being multiple copies of the map so that you would see, for instance, North America twice wrapped around, and we will accept the maximum bounds for the same reason. In the region from country function, we map a country name to a broad region, which will then be picked up on in the legend. So if the country is United States or Canada, it's in North America. If it's China or Taiwan, etc., then it's in Asia. The marker size scales with employee count, but we use a log transformation. Without it, Google and Microsoft would have markers so large they cover half the continent. The log compresses the range so that size is informative without being overwhelming. Also, in the make map function, we define the layers so you can look at one layer at a time or whatever combination you want. We have different clusters, which is the color coding, North America, Europe, Asia, or other. Build pop-up builds the pop-up window when you click on a dot. So the HTML here, it shows you the headquarters when it was founded, the number of employees. If there is a website, then it adds the company website. If there's a Wikipedia page, then it adds that. Back to the make map. To save the map, it's just one line. So 3 libraries, 3 stages, a few hundred lines of Python. But there's a limitation worth being honest about. This map only shows companies that are included on the Wikipedia article. It's a real picture, but it's far from a complete one. If we want a fuller picture, hundreds of companies, research labs, and universities, we need more data. And getting more data means a different approach. Next time, instead of scraping HTML, we'll query a structured database using a language called SparkQL. Same question, where is AI being built? But we get more than 400 results in a single API call instead of waiting forever for scraping. And with that much data, we can start doing some real analysis and some real mathematics on it. See you then.